Hey guys, it's Miss R. I'm here to show you 7.7, which is sort of just a flip of what we did in 7.3 with special products. So we are still factoring, we're just factoring some unique stuff. So this is categorizing, so whenever we did it in class, we just slid some of these into however many categories that you want. I'm going to put them by the exponent. So all of the ones on this one are not by exponent, excuse me. So there's two terms here, there's two terms there, there's three, and this one has four, so I'm going to leave that one alone. So it just depends on how you want to do it. You could, of course, you could do it by like, this one has an x to the third, that one has an x to the third, that one has an x to the third, and then you could do it by x to the seconds if you wanted. Just group those together, and that one has an x to the first. So just however you wanted to categorize it is fine. Okay, so connection to prior learning, special products, and difference of squares. So if you remember, we had some special shortcuts for solving for difference of squares and special products. So these two are being squared, and these two are very similar, but the difference is their sign in the middle is different. So I'm just going to go through and solve these. I'm going to FOIL. So the first thing, let me make this a little smaller. The first thing I'm going to do is get a color you can actually see, is do x minus 5 times x minus 5. And then if we do FOIL, it's first times first, so x squared. First times last, that's minus 5x. Insides, minus 5x. Outsides, minus 20. Oh, plus 25, excuse me. That's a negative times a negative is a positive. And then we would add these, and you would end up getting x squared minus 10x plus 25. So that's easy enough. So all you have to remember with these is that when you see a squared, it's being multiplied by itself. There are two terms here, there are two expressions, and they're being multiplied by each other. So same thing here, there are two expressions here, even if they both aren't written, and they're both being multiplied by each other. So 2 times 2 is 4, there are two x's, so 4x squared. 2 times 8 is 16, and there's an x. 2 times 8, 16, that's an x as well. And then 8 times 8 is 64. So if we were to add these middle terms, we would get 32x. Okay, great. And then, of course, the difference with this one is when you FOIL it out, the middle terms will cancel. Like it says up here, the middle terms will cancel, and you'll end up getting just 9x squared minus 1. So the middle terms are non-existent in that one. Okay, cool. So we are going to factor then. Let me make this a little bigger. Let's see if I can do that. Oh yeah, cool. I can make this a little bit bigger, and let's go ahead and factor. So I'm going to guess and check because I think that's easier for me. So 9 times 16, let's see. I can't do that in my head, so let's stick that in a calculator. 9 times 16, 144. So x squared plus 24x plus 144. Okay, so now we just have to find... Oh, excuse me, I was doing that. Weird. So we have factors of 144 that add or subtract to be 24. So there are quite a lot of factors of 144, but in my head, I can guess that it would be 12 times 12, because if you add them, you end up getting 24. So that's just me making this a little bit quicker, but you would have to list all the factors of 144 to try to get to 24. So now we would guess and check. So if it's 12 times 12, and we have a 9 in the front, then I know it's going to be 3x because our factors of 9 are 3 and 3, and 1 and 9, and 12 cannot, or 9 does not go into 12. Only 3 goes into 12. So that's how I know it's going to be 3 and 3. So plus something, 3x plus something. Let me move this down a little bit. So I know it's going to be 3x plus something and 3x plus something. And you know that this one, oh, that was a little off. Let's try that again. Whatever that is will give you 12x, and whatever this is will also give you 12x. So right away I can say if I divide 12x and 3x, I get 4 over here. Same thing over here. So I would get 4 as my constant in these two expressions. And then let's do the same thing over here. So, oh my goodness, I can't draw a straight line to save my life. Okay, so if we do 4 times 49, that's 196. 196. And then we're looking for things that add to be negative 28. So, and for this one, I don't know very many factors of 196, so I know it can be divided by 2. Yep, it can be divided by 2, that's 98. It can be divided by 4. So this is what I mean when I say list the factors. So 49 and 4. But none of these are giving me 28. If I did 196 divided by 7, that gives me 28. So I guess that's closer. If I divide by 14, oh, I get 14. Okay. And so if I add 14 and 14 together, I end up getting 28. So that's the one I wanted. Okay, great. Cool. So if I guess and check this, I need the factors of 4, which are 1 and 4, and 2 and 2. And 4 does go into 196, but it makes it 49 instead of 28, so we don't really want to use that one. Or excuse me, 4 doesn't go into 14. Only 2 goes into 14. I said that wrong. So when we're looking at these, we're looking at the factors that we found. So 1 and 4 cannot divide into 14. Only 2 can divide into 14. So that's how we know we're using 2. So 2x plus something and 2x plus something. Okay, so we know that we want that to be 14, 14x, and we know that we want this to be 14x. So if we divide 14x and 2, we end up getting 7. And this is our factors form of our trinomial up there. So that's cool. But there was an easier way we could have done that. So I'm going to show you this little trick. So we learned this a little while ago when we were learning about 7.3, when we were learning about special products and difference of squares. So we learned this a bit ago. So whenever you see something that is the product of two perfect squares like this, all you want to do is identify your A and your B. So in this case, my A would be my A is 9, and my B is 16. But if you look up here, it says the square root of A, or it says the square of A. So if my A is 9, to get it, I want to take the square root of it. Same thing with B. So I end up getting 3 for A and 4 for B. So I could check this. I could put, a and b back into my middle term here. So 2 times 3, that's 6, and then 4 times 3, that's 24, and that matches with my middle term. So I know that these two things that I found are a and b. And so now that I found these two things, I can just basically put them into this little equation here if you want like a shortcut. So it's 3 plus 4, and I know it's going to be squared. So all I did was identified my a and b from this original equation here, and I was able to find the factored form without having to go through guessing and checking or grouping or what have you. So I could do the same thing here. If I take the square root of both of these, I could find my a and b. So 49x squared, square root of that, b. Oh, 49, my bad. Not 49. I was thinking of the x squared. There we go. So our a is going to be 2x and our b is going to be 7. So now what we can do is we can stick it into our equation up here. So it would just be 2x minus 7 squared. So this is a little bit easier than doing guess and check and grouping. But if you're more comfortable with guessing and checking and grouping, then you should keep doing it that way. So for this one, it would be a talk with your neighbors thing, but since you're watching this video, we'll just skip that and I'll show you how to do it. So with the difference of squares, you actually have to use your logical thinking skills a little bit. So when we learned about multiplying things that are very similar except the middle term is different, the middle terms are opposite, so it would be, we know that the middle ones cancel. So whenever you see something like this, first you have to identify that it is a perfect square. So if I had a 1, well, 1 times 1 is 1, x times x is x squared, and 8 times 8 is 64. So those things are all squares. So I know for a fact that this is going to be a difference of squares problem. So if you take a look, all you have to do, if this is A and this is B, all I have to do is square root them to get my A and B. So this ends up being X, and that ends up being 8. So now all I got to do is put it into my problem. So x plus 8 and x minus 8. You just have to recognize that this is a perfect square and that's a perfect square. And I'm going to get rid of that because that's confusing. This is A here, and this is B. Alright, so let's try it again. So A and B. Let's get a different color. I like purple. Purple's good. So you just want to take the square root of both of these things. So 25, the square root of 25, that's 5. That's 5x. And then this is 2. So I would just put them into this equation up here where there's 1 plus and 1 minus. So 5x plus 2, 5x minus 2. It's pretty easy. I like it a lot. It's very easy to find the pattern for that one. So this would be just your opinion. What do you like better? Do you like guessing and checking and grouping, or do you prefer your patterns, or whatever you felt like? I like the patterns, but remember that the patterns can only be used with very special types of multiplying binomials. So if you have regular grouping or regular factoring with like a trinomial that isn't perfect squares, then I would recommend using grouping or guessing and checking. But that's just your opinion. Okay, so boy thinks that 64x squared minus 625 is 8x minus 20 squared. did boy make a mistake? Let's think about this for a second. So the first thing we would do if we were solving this is we would take the square root of both of these. So the square root of 64 is 8, so that's right. The square root of x, or x squared, is x, that's right. But the square root of 625 isn't 20. I think it's 25. So the square root of 625, let's figure that out. 625 square root. Yeah, it's 25. So he did make a mistake. I would say that the square root of 625 is 25, not 20. And then you could submit it. All right, so our exit ticket is factor this and look for a GCF. So it has a hint to look for a GCF. So I know that 32 has factors of 2, that's 16. That's 4 and 4. So I know that this is a perfect square. And 98, let's see. 98 and 2 and 49. 49 is 7 and 7, and that's a perfect square. So these two things are perfect squares, so it looks like I can take out a 2 from both of those, and that would make it much easier for me to solve this. Okay, so if I go with this is my A and this is my B, so I just square root each of them. So the square root of 16 is 4, the square root of x squared is x, the square root of 49 is 7, and the square root of y squared is y. So this, remember we have to put in the other one as well, would be my final answer. This whole thing. And don't forget to take out your GCF if you can. So there we go. Thanks for joining me and have a great evening.